It was great to have our beloved violin trio back again. What a great performance. Now getting back to our projects, let's welcome on stage Illona Dausse. Let's find out what Illona's project is about.
Hello, so my name is Illona Dausse, and today I will be presenting my research project that I wrote in summer of 2021 and finished in January of 2022. And it was about investigating the effects of sulfur dioxide on fruticose lichens in Luxembourg. So first I wanted to give some background information on what fruticose lichens are. So lichens are a composite organism. It's basically a fungus and an algae in a symbiotic relationship, so the mycobiont, which is the mushroom, and then the photobiont, which is the algae. They have an intricate structure, which means they have a certain sensibility to pollution, which makes them a bioindicator, which allows us to use these species in assessing the quality of the environment. They have no cuticles or roots, which means they directly take in the air from the atmosphere, and they're affected by abiotic factors such as temperature and pH. So in finding my research question, so this 4,000-word research paper was written in the context of the International Baccalaureate, and I took an approach from an environmental science perspective because I'm now an environmental science major in university. So upon, what I did first was I did some research, and I found a paper explaining lichen presence in Luxembourg. And so I was at first going to investigate the effect of roads, so roads emitting sulfur dioxide from cars. But then upon finding my area of research, I saw that there's a textile factory, which made it a more local and interesting research. So I assessed the impact of a textile factory. The factory being called Textilcord and Alschmetz, which are both sulfur dioxide emitters according to my research, because they emit based on energy production. Additionally, so I chose two sites. One that is further away from the factory, and one that is closer to the factory, to assess the impact of sulfur dioxide. And I also assessed the wind direction, so the wind would be blowing towards the lichens from the factory, which means that lichens would be affected by this sulfur dioxide that is being emitted. I chose a fruticose species because they are most sensitive to air pollution, and there's not a lot of air pollution actually in Luxembourg, which means that they will really catch on to sulfur dioxide if they're being affected. And finally, according to my research, height and abundance were proven to be significant, so I recorded the height and the abundance and also the diameter of lichens. So based on that, my research question is, to what extent has sulfur dioxide as a consequence of the development of a factory complex affected the abundance, height, and diameter of fruticose lichens, Evernia prunastri and Cladonia ciliata? And my hypothesis was that as distance from the factory increases, abundance, height, and diameter of fruticose lichens will increase as atmospheric and sulfur dioxide levels in soil decrease. So the importance and impact. To me, this research is really important because we have to be aware of the human impacts, the impacts that we have on the environment, and this is directly linked to climate change. How can we prove to industries that they're actually affecting the environment around them, even though they are saying that they're putting in certain legislation, that they're not affecting the environment, but doing this kind of research shows them directly that they need to change something about the way that they're producing things. And so the best way to do this is to investigate directly the natural environment. So my research was in Steinfurt in the Schwarzenhof, which is a natural reserve in the west of Luxembourg. And so, and from there, so I went to the reserve and I did my research. So my methodology was to do a belt transect. So a belt transect, a belt transect, which means that, so I first walked 200 meters away from the factory, from the pollution emitter, and then I did 100-meter intervals, and then from there I delimited a 5 by 5 meter area, and then I put down my quadrats. I did that 20 times using a random numbers table, which in the end covered 25% of the area, which means there's a certain limitation in my study. And from there, I recorded the height and diameter of the 4 lichens that were in the corners of the quadrats, and then to calculate an average. I recorded abiotic factors, so for example, light exposure, altitude, humidity, anything that might be that needs to be taken into consideration to draw the limitations. And then I also recorded temperature and pH using a temperature and pH probe, again to account for abiotic factors and what might be, what needs to be taken into account. And then here I have my map. So we can see that I have site A, which is 1 kilometer away from factory and roads, site B, only 200 meters away from the factory and roads, and then statistical, which is still a factory that is producing, and then Alschmetz, which is an old foundry. So we're also taking into account old emissions and the newest emissions. And so this means that my variables were, so the dependent variable was my percentage cover per quadrat, my independent variable was the distances, controlled variable, so the locations, time of year, number of trials, size of quadrat, number of trials, so 20 for each distance, and then my uncontrolled variables, which was temperature, pH, climate, human activity, which I tried to take into account as much as I could. And then I also made these like drawings, which I think really shows like what I did. So the 5 by 5 meter, and then you can see that the tiny area, the tiny square on the side is how much space 1 quadrat takes up. So I'm doing this 20 times, which doesn't cover a lot of area. And then the quadrat, actually putting it down, which shows like what I did take into account, like in like counting how many lichens were present in 1 quadrat. So here's a picture of the lichens that showing how I measured the diameter and the height, and more of the lichens, more of the pictures. And then coming on to the results, we can see that there's a clear positive correlation between the distance and the average percentage cover. So as distance increases from the factory, we have the percentage cover increases, which means there are more lichens that are present. This one was for the average percentage cover. This is for the average height, and this one is for the average diameter. So we see that for diameter, height, and abundance, so which is the percentage cover, there is a general positive correlation. So even though we see this positive correlation, it might not be statistically significant. So to account for this, I did a statistical test. So I did an average for the height, diameter, and percentage cover, and then to measure the strength of this to measure the strength of the correlation, I did a Spearman's rank, and then put a null and alternate hypothesis to show if there's a statistical or not a statistical relationship. And then I tested significance using critical values. So this shows that there is a very strong correlation. And then coming on to the analysis of my findings, so the RS value of 0.95 shows that there's a very strong correlation. And then, so with the distance, there's an increase in 35.3 in percentage cover, 3.7 for height, and 5.5 for diameter, which shows a clear increase in how well the lichens are growing. At distance 0.8, there's a jump in percentage cover, which I hypothesized could be because there is more light. Distance 0.4, there's lots of mud, so it could be unsuitable for lichen growth. And then large error bars in this show that there's cluster growth of lichens. And then in evaluating my study, what could be affecting my findings could be the varying conditions of lichens. It could, the conditions change every day, so this is not replicable. There's a possible change in altitude which might affect the growth of lichen, the way that I set up the quadrat, it might not be, I might have made some mistakes. Also, only fruticose lichens are investigated. I could have investigated other types of lichens to really show the diversity of lichens. And in conclusion, the hypothesis is not fully validated, but it is, however, supported, and it also builds onto other scientific lichen research papers. Thank you for listening.
Hello, Illona.
Hello.
How are you?
I'm good, thank you.
So I would like to know, it was your first time here, right?
Yes.
This contest. Can you tell me a little bit, how do you feel? How are you feeling right now once it's done?
I mean, I was a lot calmer than I thought I would be, to be honest. I got kind of confused with like coming off the stage, which was a little bit stressful, but other than that, like it was just explaining what I did, so it wasn't really just, it was fine, I think. Yeah.
And maybe for us, because we saw the title, it seems super interesting, but can you give us a little bit of an introduction of the project?
Yeah, so for my extended essay for IB, I chose to do a 4,000-word research paper on lichens. Basically, so as I explained, like what I did first was I looked for some research papers that indicated lichen presence in Luxembourg, and then I went to the actual areas where they said there would be lichens. And then from there, I chose to I didn't want to investigate the roads, because roads obviously they create sulfur dioxide from cars, but when I went to the actual area, I saw that there was a factory. So I wanted to investigate how the factory is affecting the lichens there. So yeah, that's how.
So basically these lichens, they shouldn't be there.
They should be there, and their growth is, and their presence is affected by the air that they take in. So,
okay.
Do you think that they can be a tracer of pollution?
That they can be what?
A tracer of pollution, that means that you can use them to see if the area is polluted
yes,
or
exactly.
not?
Exactly, yeah. And it shows basically how polluted the area is. And that was, yeah, exactly.
That's amazing. So, and how? They are incorporating the sulfur dioxide in the structure? Or can you tell us a bit more about that?
They have no cuticles or roots, which means that they take in whatever is in the atmosphere. And if there's a lot of sulfur dioxide in the atmosphere, they're taking this in, and this is inhibiting how much they can grow, for example, their height and their diameter, and how present they can be in the area. So which is why I thought, if I go further away from the factory, there's going to be more, hypothetically, and then if I'm closer to the factory, there will be less, because they're affected by the emissions.
Yeah. Did you have time to check what could be the solution, or there is no actual solution?
I mean, the thing is that there's been pollution in this area for a long time, and they're still being affected by this pollution even years after. So I'm not really sure how this could be fixed, but it's already a starting point to know that, like, if you have a factory that's emitting sulfur dioxide, you have to be aware of the impact that you're going to have on the environment, and like where the factory is located. So
yeah, it's super interesting. I think this should consider more observations and more research for sure. So talking about the contest, for someone that is about to register or is thinking about participating, do you really encourage these people to participate? Is something good? Did you I don't know, felt that it's something everyone should try once?
Yeah, I mean, if you've done this research and you want to show the world what you've done, definitely it's an amazing experience, and you talk to people who have so much more experience than you, and they give you so many opportunities. For example, one of the jury members told me, like if you want to measure the actual amount of sulfur dioxide, you can contact me, and I can give you what you need to do that, because obviously I had these there are definitely limiting factors when you're in high school. Like I didn't have anything to measure the content of sulfur dioxide. So yeah, it's really It's really lots of opportunities.
Yes, and contacts that
Yeah.
you're getting perfect.
Yeah.
I don't know if you want to ask.
Yes, I'm curious about how you get this idea. So you was walking there and you said, "Oh, there is less lichens here than here," or how you get the idea of this project, how you develop it, and what's the next? I mean,
Yeah.
if you want to do something else later.
I'd say how I came up with the idea. I mean, lichens have been investigated for a long time, so it's definitely not like a unique thing. And they're like one of the main bioindicators in the environment, which is really interesting. The fact that you can use this species to just determine if the area is polluted or not, and if, like how the environment is being affected. So yeah, it was also mainly talking to my my high school teacher, Ms. Charnot, in ISL. She talked to me about this. She was like, I've always been interested in environmental science, and she told me, you could do this. Like, this is lichens. Like, I think you would really enjoy that, and that definitely, yeah,
That's
one of the main reasons.
I have one curiosity, my own curiosity. So that's mean, could you link some specific species to the contamination, meaning that can they mutate, or do you just take not just,
Yeah.
it's very interesting, take like look at the shape, at the size, or
Yeah, exactly. So height and diameter are affected. So like the height of the lichen, like how much, like just the height, and then the how big it grows. So definitely. So that, and also different species react differently. For example, I think as I said, it's like squamulose and foliose are different types of lichens. They just have a different shape. It's not the species name, it's just a different shape of lichen. And they're less sensitive to pollution. But for example, if I actually tested for diversity in the area, I would probably see that there's more foliose and squamulose rather than I think fruticose, which is what I
that's amazing.
Yeah.
So thank you so much.
Wait, and what the next?
Yes.
What the next? What do you recommend? What would you do the next in this field of research if you would propose another project?
Does it have to be linked to lichens or something else entirely?
Up to you. What you have in your mind now?
Yeah. If I continued this, again, I'd test for diversity, because that's really the only thing I can think about, and diversity, but also actually measuring the amount of sulfur dioxide in the air. Because, I mean, I don't actually know if there's sulfur dioxide. I don't have any measurements. So really getting those measurements would be really interesting.
From the contacts.
Yeah, exactly. Yeah.
Perfect.
Exactly.
So this is great. Thank you so
Yeah.
much, and see you tomorrow, right?
Yes.
So good luck, and thank you.
Thank you. Thank you.
Thank you.